Okay, page 47 in your book goes through rules for determining significant zeros. Okay, when we do significant digits, all digits 1 through 9 are significant. You would say that they are actually part of the measurement. Sometimes zeros are part of the measurement when they're actually measured, and we'll have to be able to use these rules to see which zeros are measured, and then sometimes zeros are just placeholders in there because they're converted, and when they're converted they add zeros to either the right side or the left side of the decimal, and so because of that, those zeros are not really measured. They're just there as placeholders, or we have an estimate. We have an estimate, and you can say, oh, in Beatrice is about 14, say 14,000 people. 14,000 people, the 1 and 4 are actually, measured because we know maybe it's between 14 and 15, or I guess between 13,000 and 15, so we say about 14,000. And so those zeros behind are just estimates. Like there's about 300 million people in the United States. Well, we know that all those numbers are not counted, and so all those zeros are not significant. So I just have some basic rules that might be a little different than these, but you definitely can use these rules. They're a little bit long, but you can look at those examples. So for the first example, in the first rule, it says zeros appearing between non-zero digits are significant. So I call those sandwich zeros, and so they're always significant. So if we got a number that would be 10,000 and 10,005 meters, then we know the 5 is measured, that's in the 1 spot, and we know the 1 is measured in the 1,000 spot. And so all those zeros in between, they have to be measured. So there are what we call 5, all those digits count. They're called 5 significant digits. Now, later on, we use these for multiplying and dividing. So we're just counting right now. So on this one, we would say there's 5 sig figs. Significant figures or significant digits, however you want to do it. So sig fig we'll just do for shorthand. So those all count. So according to that first rule, when they're sandwiched in between, then they count. So like 0.503 grams, that 0 counts, so there's 3 significant digits. Any questions? Well, I guess you can't ask questions, but that's what it would be. All right? So we'll go ahead and go to the next example. The next example says, if you have zeros appearing in front of a non-zero digit, they are not significant. So these would be kind of like placeholding zeros, you could say. I always say they're leading zeros. Okay? So if you have a leading zero, if it's out in front, it's leading all the other numbers. Okay? It's not behind a non-zero digit, but I call these leading zeros. They just so give you the rule. Zeros appearing in front. So I say leading zeros don't count. So anytime you have leading zeros, they are not significant. Counted as significant. They're not part of the measurement. So leading zeros, they're placeholding zeros, 0.005. These zeros out in front of the 5, these two zeros, they are leading zeros. They do not count. Okay, I think some of this cut out, but hopefully you got it. I'm not sure where it cut out, but we were talking about trailing zeros. Trailing zeros don't count if there's no decimal. If we have a decimal, then they always count like the example down below. Okay? So trailing zeros without a decimal, they're not part of the measurement. They weren't measured before they were measured. Or I'm sorry, if there's a decimal shown, they were measured. So I'm going to go ahead and stop the recording, write these out, and then start it again. Okay. So, would like you to go ahead and write these down. There's 10 of these. I'd like you to go ahead and determine how many significant digits that are present in those examples. You can look at sample D on page 47. Okay, when you look at sample sample problem D, they give you some examples of leading zeros, trailing zeros with a decimal, trailing zeros without a decimal, kind of the rules associated with that. I'd also like you to go ahead and look at number 1 on page 48, and then I'll go ahead and the sub will have textbook, and she will have answers for those on page 48, so you can have some examples of that. And then we'll go through these answers tomorrow, and then we'll do calculations with subtraction and addition, multiplication, division, which is on page 49 through 51, 52. So you can look at that. If you want to look at how to plug in scientific notations on your conversions, they do give an example of a scientific calculator that has an exponent button that you can look at and how to use that. That's on page 52. Okay? I would say that we'll probably have a formal quiz that will be on conversions and significant digits that will take place on Wednesday. Okay, so that would be tomorrow for you. Just a way that the sub can go ahead and do those and kind of give me information how well you're doing on these when I communicate with them. And then on Thursday we'll have to do a lab, and the lab will involve density. I guess we'll do that on Friday. So we'll do density problems in that on Thursday using significant digits kind of as our answers in that. And then on Friday we'll do a lab dealing with finding the thickness of a piece of aluminum with by measuring the length and width, and then finding the depth and going through some conversions in the lab and that. We'll do that on Friday. So wish I was here, but hopefully we're able to get through this week and try to get some of this stuff figured out. And so tomorrow we'll go through these answers. You have examples on page 47 and 48 you can look at. And then, like I said, Wednesday we'll have a kind of a quiz that you'll do, formal quiz, and then sub will grade it, give me back information how you're doing on that so I can plan. And then we'll do density on Thursday. You guys just have to probably do that. I probably won't have a tutorial or anything. And then on Friday we'll do a lab, aluminum lab and that. And you guys can do that and probably ask questions that following Monday.